basics of building my own operating system. We're doing a bit of an evening session today as my lighting's kind of messed up, super dark in my room. I don't know if this is better, but we are doing it. So as usual, hello. How about chat? So today's topic is going to be logging, as in print statements, because yo, what's up, Tugra? So like last week we got the very first tiny bit of output working finally. So basically deleted the whole legacy OS and basically have a completely blank kernel now. And after a little bit of trial and error, we finally got it to the point where it prints an A onto the serial output. And that is where we stopped. And so going forward, it would probably be really useful to have some logging functionality to print some messages. So that's what I'm going to focus on today and try to expand a little bit on that A that we got working last week and carry it forward a little bit more, make it a bit more featureful. Just checking that the tweet went out, and I think it hopefully did. Yes, sir. Okay. Nice one. Got the music going. Discord message got sent out. So let's like just get started. Okay, so that's all fun. And just a review of the Git. So, okay, so last time, this is mostly what we were doing. Removing, deleting lots of files, deleting lots of unused code and build system scripts and stuff like this. And then we added our basic K main. And if you were watching last week, I had some trouble getting the E9 port working, which is this QEMU hack for just getting output really conveniently out of QEMU. Turns out I was missing a command line argument. I need the debug command line argument to enable the E9 port. So that's all working. And then after that, this was off stream, but I just Clang formatted the code base. So now I'm going to start with a new branch and call it the logging branch. I'll also fire a test1 in the chat. See if the chat widget is waking up. All right, there it goes. Nice. So I should probably open up the code. Thank you, Catflare. Welcome right back to you. So, okay, before we start, I'm sort of considering a bit how to proceed here. So this is what we have so far. And the goal is to convert this into something that's a bit more like this. Hello world. Yes, fresh start indeed. Thank you. Yeah, I'm pretty nervous actually, because this is much more real than any of the work I was doing in the past, which was based on JOS. But I am feeling optimistic. Anyway, this is sort of my desired end state to get to. I want to just be able to, at arbitrary points in the kernel, be able to log messages to the kernel's log. No, sir, I did not call any CTORs at all. So maybe we'll need to do that. But so far, haven't run into that yet. Because I don't have any global objects, but maybe I will add one. So that will be part of the work. So yeah, that's probably what I'll try to work towards today. But maybe before that, though, I feel like I want to delete some more files. Slightly rearrange things. I deleted a lot of code last time, but we still have some lingering stuff. Oh, yo, what's up, Akhil? Nice to see you here. Appreciate it. Hope you're having a nice one. So yeah, I'm going to, so at this point we're not using any of these. We're using only a couple of these files, like xx runtime and x86.h. So I will just take the liberty of deleting more stuff. Cafware is implementing, it's going to implement allocating vectors in the IDT. Right on. All right, what's the, can you give us a bit of context around that? Are you, which OS are you working on? Because you have quite a few. Okay. So I'm going to go into my current directory and I'm just going to start deleting things. For example, I'm going to delete the console driver because I want to actually add my own. So do that. I'm going to delete the K clock. Going to delete the monitor. Delete the pick IRQ. Current OS, but I unnamed it. Want to name it in the end. Nice one. That's exactly my strategy also. No names for right now. Just code. All right, I'll delete. I mean, we will. I foresee needing the multiboot header, but maybe I will just delete that also, just to really clean things out. So here's a more minimal collection of what we need. Test CPP is just like sort of kind of there, but not really used, but I'll keep it around as a useful reference. And I guess, yeah, init.c is also not needed. That was the old main, old K main, basically. So yes, okay, good. And then I'm just going to go into here, inc. Yeah, I'm going to move x86.h into kern just for simplicity. And then I might, error.h is just these enums. And assert.h is kind of interesting, has this macro, but yeah, really none of this is used. If I ever need it, I can reference my other, like the old code, and bring stuff back that I need. But I think I'm just going to delete the include directory. So I need to adjust this include because x86 got moved. And let's just try to build. Yeah, CP. And now why? Oh, base. It's building base. So base is kind of interesting. Print format. .c. Also not needed. Read line, also not needed. Yeah, you know, let's do this. Let's just go ultimate simplicity and just move everything into the current directory. This is like kind of just boring work, but no more fancy base lib stuff like this. I'm just going to bring it into a really minimal state and we'll build back up from there. What is... Okay, these were some functions that we actually did need apparently for some ETL stuff, maybe. So I will keep these around also. Oops. wchar. Sure. Files of somewhat questionable provenance. Okay, so these are empty, so this is all just gonna, this file didn't really do very much anyway. So nice, we're gonna clean this out too. And base, no more base needed. So now let's try building again. Entry page dir. Okay, so here's where entry page dir actually did. We actually did need mem layout. So I will bring that back from the dead. But I will move it into kern. Page dir. So now sort of, oh, MMU was needed also. Ouch, okay. Okay, and likewise, we'll just move it all back in there. So how about now? Mem layout also needs to be patched. Oh, and types, okay. Unfortunate. Maybe we can get rid of that later, but for now I'm just taking the easy path. Okay, what about now? MMU. Oh no. Tree.s. Oh, trap. What? Why is... Okay, I don't... It's not important. We'll just deal with it. Okay. And you know what? Oh, actually, okay. So multiboot. All right, I will keep it around. I will just keep it around for the sake of not breaking too much. So now does it build? Need to move. I think trap.h_kern. We're getting closer, I think, though. 86.h needs types. And CXX runtime, interesting. So that is it uses assert.ho. Okay. A bit ugly. Okay, what do we do here? Sound.hpp. So, and actually this is technically not even needed here. This is more of the CPP file kind of thing for all these panics. But if I recall correctly, panic was, it's like defined in the init.c, which was kind of weird. Okay, here's what I'm going to do. I don't really want to bring back this assert.h. I sort of want to make my own, but now's not exactly the moment to do that, so I'll just make my own panic function that just does nothing for right now. And then later we'll check it out and add a print statement. Oops. Okay, so to do add print statement once we have logging. Okay, quick check on the stream. 9 people in the stream, that's cool. Let me update the text in the stream window. So today we are working on logging. Okay, so how about now? CXX runtime. Okay, stupid mistake or what? What's up, Ruggiel? Welcome. Non-void function does not return a value. What? What? Oh, wait, do I, sub dash. Non-void function does not return a value. What? Non-void function, what do you mean non-void? Maybe okay, so this can go away. So what's going on here? Line 23. Void star. And why is this only happening now? Oh, it's because oh, wait, is it because I re-enabled W error. Oh. Renew. I'm just going to try to make the compiler happy. Does not match previous declaration. R. In declaration does not match. What previous declaration is it talking about? Okay, this is annoying and not really worth fixing, so I'm just going to add back the the comment here. Okay, jeez. But now it's building again, which is good. So let's make a commit. Delete, delete, delete. Okay, base gets deleted. CMake gets slightly tweaked. Okay. Ink gets deleted, kern gets kind of tweaked, things get moved into it, and a lot of stuff gets deleted. Okay, so let's make a commit. Move remaining JAS files. Okay, cool. So now we have a bit more of that clean slate that I wanted to get. And, so yeah, there's all these constants in mem layout.h. And the the entry page tables depend on them. But mostly just kern base. So, yeah. All right, well, that will be something we can change later if we want to. Okay. All right. C++. Okay. K-main. Cool. So now I might also just take this opportunity. There's like all these lingering pieces of JAWS everywhere. JAWS, I'm just gonna quickly just add stuff like this to make that a bit more clear. Right, JAWS. You know what, I'm not even gonna bother. There's just too many files in this, like, kind of, it's pretty clear which ones they are, so I'm just not gonna worry about that for now. Okay, so then just taking a quick check out the, so actually this could have gone into that commit also. So I'll just amend that quickly. Okay. Okay, nice. So let's get started with this logging. So, yeah, let's just touch logging.hpp, pragma once. Okay, and my vision for this function is that I actually don't even know if we're going to have a CPP, but it is going to just forward its arguments to frig, basically. So it's a good time to pull up test.cpp because, which no longer compiles, but basically we already have frig working, and frig has this nice formatting, which I've been using. And I think I'll just keep using that. So it's going to look something like this, I think. And we're going to have some, but the thing is this, I'm just going to sketch it all out here. This is going to be a variadic function that forwards all of its arguments to, I'll actually also rename the file. I'm going to start using capital letters. Y already exists. Wait, what? Oh, okay. Actually, it seems like frig already has its own logging. This is like in-memory logging, which I'm not really doing right now. So I'm just doing direct output. So anyway, so let's just try to sketch this out, and I might lean on AI a little bit here. Open chat. Please make this a variadic function that takes a dynamic number of arguments and then is able to forward them to another function. I believe this uses parameter packs. I don't know C++ well enough to code this directly from memory, so I'm going to ask for help. What's up, Kundan? Have I shifted to C++? Yes, I have. It's a development or C++ learning practice video. It's a bit of both. I'm working on my operating system, but it is very much a learning process, and so it's a bit of both. But I'm trying to build stuff, so be kind of practical with it. Can I not keep this? But this is pretty much exactly what I wanted. Keep. Great. So the only thing missing is the sync. And the sync depends on basically an output function. So yeah, so the way all this formatting is done is very cumbersome. You have to pass the sync in all over the place. So the sync is probably going to be a global object, or not. I mean, not necessarily. It's cheap enough to make. Interesting. These files are still named with the lowercase. Reload the window. Okay, I don't know. Right, it's writing to it anyway. Okay, but so we're forwarding. But okay, so wait, no, it's frig dot format, but we need frig dot fmt is the one that receives all the arguments, and then sync. Just for illustration, so and again, doing this in sort of just the most direct kind of messy way. So we'll just directly depend on this here, and what is it? It's out B hex E9C, and then to print a string, we will need. I mean, we can just do that in a loop. All right. How does that look? While string points to something, we're going to call the append and bump it. What's up, Ariel K? Thanks for joining. And maybe instead of my sync, we'll call it call it output sync. Maybe this thing comes up because it's a little bit shorter. So we have that. And now Then we can just construct the output sync. All right. Quickly checking in on the YouTube stream. 13 people. Awesome. Thank you to each and every one of you for checking out the stream. Okay, so theoretically, this is our log function, and it's just sort of taking what we were playing with earlier and making it, just putting it into this function. So now it should be ideally a bit more convenience to do some logging if we wanted to do that. So let's take that for a test run. Age of 5 really love your channel. Real metal programming stuff. Thank you, Kudon. I mean, I'm still using AI, to be clear, but I'm trying to avoid vibe coding as much as possible so I can actually learn something. Okay, so we're gonna build the kernel, and it doesn't compile. Oh shit. Expected an L value for second. Okay, let's rewind one thing. Let me just hard code something here. Oh, it must be an L value. That's right. For some reason, this thing it needs to be an L value. So we actually, for some reason, we do need this to be just a sync. Okay, let's just try this out. Does this, no. No matching call to format. What? What? Oh, this thing was also called this got renamed actually. It should be called MySync. Okay, even rewinding one step further, let's just directly call this here. Forget the log function. Actually, wait a sec. Yeah. Frig. And let's just forget that. What? Okay, so that built and ran. Good. Print list. For some reason, the bunch seemed to print a little bit. I was just noticing why the cursor is all the way over here. Makes it seem like it printed too much. But, yep. Get rid of the new line. I wonder if that's it. What's up, Dis? Still doing the labs? No, I'm not doing the MIT stuff anymore. I finished that probably a little bit ago, and then now I'm just kind of doing my own thing. I've just kind of started over with my own operating system. I think I finished the MIT stuff about 6 months ago. And then since then, I was just working on getting things set up with like C++ and a nice build system and using a lean-mine bootloader and integrating a bunch of third-party libraries that I want to be able to use. But now I finished all that, so there's nothing else to do other than just like start the OS. So this worked. So the direct bear call just worked. Starting pretty much 99% fresh. I am keeping a couple JOS things around for the boot process, and so I'm keeping the JOS like boot assembly and a bit of the early page tables stuff. I might change that later, but I was mostly just interested in taking control once we shift into C++ and then kind of going from there. What's up, Coders Lo-Fi Station? Nice to see you again too. So what is going on here? So that all worked quite nicely. And then as soon as I try to use the log function, it's not compiling anymore. No measuring function call to format. Because outputting does not satisfy sync. Ah, interesting. Why not? What? Sync. How does... Oh, whoops. You're telling me that sync does not... Wait, does the... No, wait. The order doesn't matter, surely. Because T dot... Maybe... No. Okay, this is the annoying part that so formatting 31, does this work? T dot append const char star stir. So, like, pretty sure that's here. Also, let's get that break timer going. I'm just going to go ahead and take 20 seconds, be right back. All right, I'm gonna let Claude cook on this. Can you debug the compile error, please? cd into the b dir and run make. Okay. Yes. Oh, I'm creating a const sync. Stupid me. What? It requires... There's okay. That's okay. There we go. Okay, so cool. That was helpful. Okay, so that is working now. Now for the final thing, back to here. Does this work? Okay. Can you please debug the new compile error? Template specialization. But here's the thing, I thought I was forwarding all arguments. So wait, what? Oh wait, okay, that's okay. Okay, there we go, nice. Okay, that's cool. So check it out. So that looks good. So now we have hello world, but not only do we have hello world, we can do the forwarding, the forwarding. So X, Y, and now we can do format printing. Check that out. Hello world 420. Okay, that is cool. So that is definitely nicer than we had before. So so now got some logging. That feels really good. The most basic form of logging you can imagine. And what is the first log message? Starting up. Okay, main. Started. Okay, so it smells like time for another commit. And drop this one. So, and actually, there's no logging. There's no logging.cpp actually. This is all in the header file because this is a template. So goodbye logging.cpp. And do we do anything different here? I'm kind of envisioning a future where we have different logging syncs. So this one is directly using the Kimu debug port, but it might be nice to have another one that doesn't do that and uses the serial out once we have a driver for that. But that can all come later. I think I'm okay just to keep this like this for now. And check out this Clang formatting on save. That's pretty nice. Okay, so that's cool. Add basic logging. Yeah. also realized I didn't really make a plan for today. Also, it's probably time for another one of these frames, but I didn't really mean to make a copy per se, so is there an easy way for me to just make it? All right, I'll just copy this one. It's a bit smaller, slightly, but now I need to go ahead and delete like everything here. Okay, cool. So today is the 19th and 86. So what's the screenshot we got? Got our formatted print. Wow, very small. Okay. Why? This is all super small. Logging. Done. Let's check out the roadmap. So assertions / panic sort of comes next. And we sort of did this. Okay. So assertions, I guess. So is it time to merge that branch? No, I'm just gonna, I don't know, we can do multiple things in one branch. So now that we have our logging, I want to have a bit of panicking / assertion functionality, because I also consider that a pretty important prerequisite. Actually, wait, so, well, we kind of already, I added that CXX runtime. This was that thing that was low-key, weirdly panicking. So what do we need? We kind of need two things, I guess. So the first thing I'm envisioning is an assert macro. And, you know, for example, if we were to take out my func int x, something like this, we might, or I don't know, a pointer or something, we might use the assert macro to assert that it is not null pointer. Just like basic stuff like this. And I'm just gonna, let's just add that. So I'm going to touch assert. Well, before I do that, so that's one thing I want. I want to have an assert macro. And the reason it's a macro is because I don't, like, I want it to actually be able to print out into the console the source code of what is being asserted. And if you use a function, then it just all gets turned into a bool and it's just sort of erased. And you're not able to print out that that source code of the assertion, so that's why it's a macro. Also, it slightly helps with, I guess, the debug experience, because the assert sort of happens in the function that you just see here. It's not failing in the assert function itself, but it's going to fail in the client conceptually. So anyway, that's one thing. So the other thing is, it seems like we need to panic, where we just panic with a message, like hard panic. And maybe for consistency, I'll make that a macro also. Yeah. Alternatively, the assert could have a message associated with it, but I don't know if I really want that exactly. So I'm just going to try to make my own assert infrastructure. And what's the name of this file? assert.hpp debug. I'll just call it assert.hpp. Okay, assert.hpp. Once okay. And here's where I don't know how to really write macros, so I might lean a little bit on the old JOS code base, which sort of does a little bit of this. So, but I'm just gonna try. So we're gonna define assert, and I really don't. What do you do with this? You give it a thing, okay. Condition. And then here's the part where you need to start adding backslashes everywhere. So here's the code that I want to write. If condition. And then here's where we're going to use we're going to depend on our logging. I literally don't know how to do this. Do I need the last one? Okay. But Clang format is doing this cool thing where it somehow is formatting that. So condition. Then what happens? Assertion failed. I'm just going to do this for now. Okay, maybe I do need this. Maybe I do need that. Maybe not. And then what happens when an assertion fails? We infinite loop, maybe. We just need to stop things. Not really sure how that's going to work with multi-core. But does looping? What's the question? Does looping here work for multi-core? Probably not. Okay, but for the moment, this is going to be my basic test, and so I'm just going to assert that x is less than 2. So this is going to fail, and I'm going to assert K-main is going to start, and then we're going to fail the assertion. And I'm just curious about that. So let's try it out, but it doesn't compile because I messed something up. Okay, one more. Can I just put this here just to be safe? Okay, nice. So my K-main doesn't have the new line. Maybe that's annoying. Maybe I want to always add a new line. Yeah, probably. Like, why would I ever want to not have a new line? So, just gonna do sync.append. Oh, right, let's try that one more time. Oops, nope. Something is very interesting about the new line. Why did it indent so far? Something is like seems kind of off here. But if I add the new lines here, what happens? Okay, same thing. Okay, this is weird. Not so pleased with that. Yo, what's up, John? Happy Friday. This is one of these rare nighttime sessions. Yeah, thank you. It's scary. John with the clutch reset, appreciate that. So, there we go. Carriage return, that's crazy. Appreciate that. Okay, sick. So, got the logging going, that's great. And the assertion is also going, so let's actually make it good. So, we probably want to, I don't know, print out, isn't there like some file? It's like file and line or something like that. And then what, the condition? Something like this? Is that what an assertion looks like? But I have obviously messed this up. So right. So this is, we're getting somewhere, not exactly where we want to be. File, line, and then how do I make the condition print the actual string? Oh, the pound, okay, need the old pound sign. Nice. Stringifies it. All right, that's cool. I don't really love, is there like a way to get not the full file path? Was there like file name? Okay. That's looking pretty good. Pretty happy with that. Just add a space here maybe. Sure, I'll take it. So nice. So got a little bit of assertion infrastructure going. Anything else to do while we're here? I guess not. I guess this is just a all right, so this is actually going to go into here, and this is its own commit. Add basic assertion. But actually I wanted the panic also. So that's going to be, I guess, sort of the same thing, except it's just sort of condition its message, and there's but don't I need like a do while 0 or some weird thing like that? Isn't that like how you do macro programming? For some reason, I feel like I saw this somewhere. Oh dang, what? I feel like there is some reason to use a do while 0 when you use something along the lines of it makes it, I don't know. You can put you can put a, I don't even know. I just remember seeing that somewhere. Okay, so maybe I just do the same thing here. And panic. And it's kind of the same thing, I guess. So let me just try that. For macros multiple lines, you put it as the body of a braceless if statement, only part of it. Yeah. Okay. So I don't plan on using single like braceless if statements, but just in case, I'll just keep this here. So panicking, let's check that out. In quotes, that's kind of funny. Maybe I don't use the stringify thing. Panicking, okay. All right. So fairly happy with that. So now I can replace this while one with reached end of kernel. Cool. And so now this thing gets amended into here, and this thing also gets amended into here. So now So we add this thing and make that change. Cool. Next, we can change this back to include assert.hpp. So now we can get rid of this, and all these things become panics. Something like that. All right, cool. Just checking in on the stream, right? What's up to the 15 people in the stream? Okay, so now we can fix the infosec runtime now that we have make runtime use panic macro. Okay. So far, so good. So far, nothing too crazy going on here. Got some assertions. Got some panicking. Sick. What's next? Unit testing, I don't know. Maybe that's a little bit for later. Was kind of curious what it would be like to write unit tests for parts of the kernel and then link them into a binary that runs on my host machine. But yeah, I don't know. Not really feeling like doing that right now. Can always do that later. Which sort of means it's sort of kind of time to get into some more interesting stuff. Like actually starting to boot. Or maybe perhaps porting some of the boot code from JOS or something like that. Or maybe time just to do some command line arguments type of stuff, because that sounds like also something that might be kind of useful to have somehow. But I mean, maybe we just take a moment to pause and acknowledge that the base project infrastructure project is kind of done. That was just something I started a while ago when I was just getting all the C++ stuff going, using Clang, LLDB, checking out all these standard template libraries, Clang format, printing, and assertions. So that's pretty cool. Yeah, I guess let's merge that branch. I'm gonna rename it to logging and asserts. What's up, Jimothy Sherwood? Yes, it is Sunday already. Yeah, I'm not able to stream on Sunday this week, so I'm trying to do it a bit early. Yeah, I used to just pre-record streams when I couldn't do it on Sundays, but I don't know, I kind of changed my mind. I feel like those are just like not that fun to watch for anybody. So I just try to do it at a different time. All right, so looks good. Let's merge this. Okay. And let's check out some of this command line parsing stuff. So this will be interesting because it will involve multiboot. It will involve a couple things. So, excuse me, multiboot, and then I am not super interested in really writing a command line option parser exactly. So that's sort of why I was interested in Frig also, because I don't know, it has one or something like that. So I guess I'll just try to figure out how to use that. So yeah, that sounds fun. CLI args. Okay, so what do we do from here? Multiboot 2 is this header file. And I added like super basic parsing to JOS just to do a proof of concept of command line parsing. And so the way that works is that, so our main function gets actually passed a pointer to the multiboot header, and then we can parse the header. And it's like you need to walk this, I don't know, TLV, like type tag length value list sort of thing. And then once you find the command line tag, you can access this string. So this will be kind of interesting because it will require us to receive the pointer, convert it into a kernel virtual address, and then work with it or something. So, so hopefully this will be sort of interesting to work on, actually. And for I think it'll be kind of a deceptively simple project because it's actually going to require a couple of different things. So fizz to vert mapping. All right, 20 seconds, be right back. Okay, so and then maybe fizz, like a fizz adder type. That was pretty useful in JOS. But for the moment, I'll just maybe make it UN32T boot header, something weird like that. And it's a pointer. but so the reason I don't really want to declare it as a void star is because that is sort of confusing, because it makes it seem like it's a kernel virtual address, which it's not. So the JOS style of handling that was to use this phys-adder type def, just to make a kind of different container for that. And I think that's probably a good idea. But yeah, so we should probably have a type def or something like that. So how about this? Phys-adder p multiboot header. This should probably go in a different place, like, I don't know, it's such a widely used thing, but like memory.hpp or something like that. But for the moment, I'll just keep it like this. Well, okay, so now that's all great. Let me just double check the entry.s though. So push ebx, that's the key thing here. That pushes the pointer, so that's still intact. I don't know, I could log it just to play around. Multiboot header received, and I wonder if I can, so how, just do, I wonder if this works. I didn't really even test this out, but I think Frig has the formatting and everything, so just curious. Hex 10,000, which seems about right. I could also maybe cast this to a pointer. And not even do, why is there a squiggly line? Invalid type conversion. Oh. Okay. And then not even worry about the formatting. Or maybe it's just easier to format it. Okay. So actually, we're missing some pretty important stuff, actually, which I'm just going to emergency copy in immediately. String.h, so current.cmake lists string.c. Okay, good. So this is super important and comes from JOS. But I think this this a bit shorter. Okay. Ooh, what? So now string.c, string.ho. So this types.h is kind of unfortunate that this types.h thing is kind of lingering around. And the question is it really even needed anymore? Types.h was this weird thing in JOS that defines all these basic C types, but I never really understood it. The compiler comes with int, right? Or actually, which way does the type def go? I don't even. How do I read this? I always forget which way. Is it saying that uint8t is an alias for unsigned char? I think it's the it's the opposite of a using statement, I think. So this is super slow. Okay, so the new name's on the right. So here it is initializing all these fixed width types. Oh, because I guess those are defined in the header usually. Okay, what happens if I just don't have this? Does it totally break? Wow, it turns out things kind of do break. You don't get size t for free. Interesting. So unfortunately types.h lives another day. I wonder, but wait a sec. But I have all these crazy third-party libraries, including like a pretty legit set of C headers and C++ headers. So I probably have a studint.h that I can use. Like I literally have student.h available, so does this not work? Or what is it, like stud type? arg.h? No, this is for VA list, I think. Just curious what happens if I try to compile it with, okay, that still does not work. So we're just gonna keep types.h around. Cool. So that's good. All right, so hopefully things are working. Things are working. Nice. So So this is not related at all to CLI args, but it's just related to overall correctness. So I will just wait, that was not what I meant to do. So I'm going to unstage a couple lines. There we go. Actually, also don't need that either. Actually, you know, actually we don't need. We actually do not need. Alright, but now this starts to look super messed up. So really the goal is what I want to add a new include. Let me try this in fork. Just curious if it's any different. So so far, so good. Okay, that's annoying. Oh, okay, here's what I'm going to do. I'm just going to make a copy of this whole thing and delete the parts, just manually revert the things I don't want. That looks pretty good. Quick commit, and then add this back. So now this is our whip multiboot args, something like that. Include string, clear the BSS. I don't know why it's called e-data. Oh, it's at the end of the kernel. I mean, we could even make this e-data. Call this BSS start. Is that clearer? I feel like it is. Or maybe just BSS. And end. Yeah, it's probably clearer, right? So now we don't even need to have that comment there. Just right. E-data and BSS. let's do it. Ship it. And clear BSS. Okay, cool. All right. So now back to this multiboot stuff. So first things first, we need to convert this to a kernel virtual address, which means we need to get into the core topic of like memory, kind of. So like we need some memory conversion functions. At least we need one single memory conversion function, which is to convert from the k-adder, no, for the p-adder to the k-adder. And yeah, let's take a moment to think about that. So this is probably going to be in a new header. And I don't know, do I call it memory? Is that too opaque? Maybe I'll call it virtual memory.h. I don't know. Maybe I'll just call it memory. That's kind of short and concise. Okay, so because I'm sort of inheriting the JOS design, I think I need to keep doing things kind of a similar way. Yo, Ismail, what is up? Good evening. Welcome to the night kernel hacking, the rare night kernel hacking vibe. Yeah, we are. Yeah, no, it's a rare night stream. I'm not available this Sunday, so I'm doing it earlier. Yeah. I mean, yeah. Check out this kernel though. We got our logging function, which is pretty cool. It's just using frig in the back end. We can do our nice formatting and stuff like this. We got our panic macro. So yeah, things are looking pretty good. And now trying to figure out how to port a bit of this command line argument parsing code over into the new world. So I'm just going to sketch something out. So this stuff you rolled in your own OS or built in. So this is all stuff from today's stream. This is all code I wrote today, basically. It's macros, but a lot of it just uses a lot of that frig stuff that we were prototyping in the last couple months or weeks or whatever. Yep. And you arrived just in time for something interesting. So now we need to figure out what to do about this. What's the equivalent of the weird k-adder and p-adder macros in the new world. I mean, first of all, look at how, like, it's so, it's incredibly funny and odd that it is like macros that go into like this inline function with the underscore, which takes a file name. It's like kind of crazy. So I'm definitely not trying to replicate this. Really, I think, I don't know. Minimally, what we need is like some kind of conversion function from phys-adder to vert or something like this. And it's going to, I am sort of using this thing of, why? Oh, do I? Dang, okay. Ouch, I guess I need to include types.h. Okay, so then we have the phys-adder. What's the advantages of using macro instead of just a function? So yeah, good question. So in general, in this code we were looking at like JOS, it's like the JOS OS, and it's written in C. And so just in general, there's a lot more reasons to use macros in C than in C++. In C, you need to use macros to like defeat the type system. If you want to write generic code that sort of like doesn't need to worry about what the types are being passed in, you need to use macros, and it gets kind of ugly. Although I don't know, I haven't really written a lot of significant C code like that, but from my perspective, it gets pretty ugly. But I chose to use macros, even though I'm using C++ for the assert functionality, because there are some properties that I want specifically from macros. So, so the first thing is that I want these lines that say assertion. So the first thing, I want the assert to be able to print out the actual source code that failed. So here's a screenshot. I want to literally see the piece of source code with the condition in the text. And if I made this a function, like a C++ function, I would not be able to do that because it would all get just erased into like a single bool. And I would just print out like 0 basically here. And so the macro specifically allows me to capture that source code text string and print that out. The second reason is I want to be able to print out the file name and line number of that line of source code. And in order to have that happen, I need this code to really be inlined directly into the actual calling code. So yeah. All right, 20 seconds, be right back. Okay, so yeah, I don't know if I would call macros powerful per se. I mean, sort of. They are a feature that is sometimes useful, but my understanding is that in general, they should be avoided. So, yes. Okay, so phys to vert, I don't know, this is like a random function. And so here's where we're kind of just following in the tradition of JOS in terms of the design of the virtual memory, in which there is a fixed, like a fixed region of virtual memory that directly maps all of physical memory. And it begins at this thing called the kernel base. And so that just means anytime we have a physical address to deal with, all we need to do is just add that physical address plus kernel base, and it just immediately resolves it to that equivalent address in the kernel physical memory. And it's just one way to design your virtual memory, but it's a pretty common strategy. So yeah, I'm just gonna keep doing that. So concretely, I just need to basically just write a function that does adder plus kernel base, but now this is gonna kind of suck. I'm going to need to include mem layout from the legacy JOS code. And this is going to become a void star, and I probably need to, what's kernel base though? It's literally, it's an int. So static cast, I don't know if static cast will work. I think it did not work last time, so I think I need to reinterpret cast. Good question, Dis. I don't totally know. I definitely find it fun. I'm not totally sure if I want to work in the industry per se, but I'll give it a maybe. Okay. So, but then they they have this assertion where if you try to convert a physical address that exceeds the amount of physical memory, then it asserts. And so that's not something I can do yet because I don't know how much physical memory there is yet. At least I haven't added the code for that. But, and in order to get that, that's in multiboot, which we're trying to get. So for the moment, I'm just going to do this. And it's like kind of okay. I wonder, naming. Maybe it's time to bike shed on naming a little bit. Fizz to vert, vert from fizz. Or just, I mean, you used kadder, vert adder, v adder, make it super short. Do I believe there are opportunities in this niche field? I definitely do believe there are opportunities. Yeah, getting your foot in the door is maybe a bit of a different question, but no, I definitely do think there are opportunities, and I think it is possible to get them even as maybe a more entry-level person. But but you will probably need to work pretty hard to do that. Yeah, it's probably less plentiful than web dev jobs. But there's a lot of hardware companies in the world, a lot of embedded. So, yeah. Okay, maybe I will be a bit daring. Like, this is like kind of ugly. I don't know, vert adder. And then just let the all right, you know, I'm just gonna keep it like this, and let's not like shed any more about that. Okay, fizz2 vert, whatever. So yeah, I feel like naming is kind of an interesting question, like how. All right, check this out. Look at that, my Clang format sorts my includes for me. That's pretty cool. Yeah, naming is kind of interesting. It's this trade-off between how verbose you want to be and potentially clear you want to be versus how much it kind of uglifies your code. It just makes it noisy. So, but yeah, let's just go with that. So, yeah, so if you have a degree in CS, I feel like you have a solid start. Yeah, no reason why you can't learn a lot of this stuff on your own. All right, so let's check it out. So now it's time to parse the multiboot header or something. Maybe I will make a file called multiboot. But actually, wait a sec. So I've done something kind of weird, and I've made this. I've defined a function in the HPP file, which is not really good to do, and it's not causing problems yet. But as soon as I have another source file that tries to use the function, there's going to be a linker error for duplicate symbols. So time to whip out a CPP file. And there we go. So this is include memory.hpp. Yeah, no worries, Diz. Thanks for popping in. Oh, we're gonna need to add this to the CMake lists. Thank you, Dash. I think it's looking pretty okay also. Let me clean out some of these tabs. Let's see, kernel LD. All right, so I mean, just to make auto p header, let's just fizz2 vert p multiboot header, you know, and just does it compile? We're compiling, and let's just print out This is not really going to be that interesting. Revert. I'm just gonna, but just to see some numbers on the screen, check it out. That's a big address. That's in our current base region. So our conversion function with the simple addition is working. Memory layout.h would be great to delete this. Because there's a lot of, I'm not going to totally use the JAWS memory layout because it's kind of complicated, and I would like to make it simpler. So, so maybe I don't need kern base. Maybe I can start doing my own stuff. And defining my own constants. And I guess memory.hpp is a decent place. Go kern base. I'll keep this, but I'll make the F smaller. So now we don't have the dependency on mem layout anymore. And I don't know, something like that maybe. Yeah, just trying to avoid including JAWS headers if I can. And yeah, so many opportunities to bike shed all over the place, like what names to choose for what, but I'm just used to this K convention where you just put K in front of constants. So I think I might just go with that also. Okay, so maybe it's time to make a commit. So we're gonna add our memory. And then what happened over here? No, it's not a Linux thing. I don't think Linux does this. You can find this convention in just like all sorts of code bases, like C and C++ code bases all over the internet. A lot of the Apple I/O kit stuff uses this as far as I know. I don't really know where it comes from. I don't even know what it stands for. I think it stands for constant with a K, which like maybe it comes from German or something like that. I'm kind of just what's the word? Cargo culting that, but I think it's useful to have some kind of indication clearly visible in the variable name that this thing is a global constant. So all right, so I'm not going to commit the K main just yet. I'm just going to commit add memory.hpp. Something like that. All right. So we're on our way. So now time to technically now it's time to parse the multiboot header. and that would be great to continue with if I had more time, but unfortunately I don't have more time. So I think this is going to be it for today's stream, actually, and this week's stream. But we'll get into this next time and hopefully parse some multiboot stuff and get those command line arguments out of there. So yeah, that's going to be it for today, everyone. Thanks a lot for joining. I will pop the Discord link in here, and I think that's going to be it. So yeah, all right, have a great one, guys. So yeah, there's no stream this weekend because I just did this one just now, and then actually in the next week I will need to do a pre-recorded one because I'm going on a trip. And so this weekend won't be there. The week after will be pre-recorded, and then I'll be back the week after. So, all right, have a nice one, and I'll see you next time. Peace.